Okay, I love those answers, everybody. Those are some great answers. I know there's a lot of really interesting things going on that you got to see today. So, my name is Mr. Nathan Selikoff. I'm one of the artists. I think you saw some of my work in the hardware store gallery. And I'm going to talk to you for the next 15 minutes or so about some of the concepts behind the things that I do and how I learn this and a little bit behind the scenes of this kind of artwork. But first, I want to talk to you about language. How many of you speak English? How many of you speak Spanish? How many of you speak another language? Okay, so we use language to communicate with each other, right? If I'm in the same room with you, we've all gone through a process of learning our alphabet, and we've learned words, and we've learned how to make sentences, and that allows us to talk to one another and to share concepts and to have a conversation. And when we say certain words, we're both on the same page. We know what each other are talking about because we've learned this common language, right? Can you talk to a computer?
Yes.
Okay. If you want to talk to a computer, what language would you use? Okay. So if you're talking to Siri on an iPhone, she understands a whole lot of languages, right? What if you need to talk to? What if you want to make something like Siri? Okay. Siri is a computer program, right? That somebody had to make for the iPhone so that you could talk to them, right? So let's talk about some of the languages that computers speak. What do you see there?
Zeros in a computer.
Zeros and ones.
I see ones and zeros.
I see binary code.
Binary code, man, somebody's advanced here. So binary code, raise your hand if you've heard of binary code. Wow, you guys are like, I'm going to fly through this stuff. Okay, so at a very low level, computers understand ones and zeros. And the ones and the zeros stand for on and off. So all the little computer chips that are inside your phone and inside your computer, that's at a very, very low level, that's what they understand. Okay? But as humans, we look at this and we think, okay, well, the computer might understand that, but I don't understand that. I'm not going to spend all my time writing ones and zeros to talk to a computer, right? So as humans, we develop other things. This is called assembly code. So think of this as like layering a cake. At the bottom, we've got binary code, and that's what the computers understand. Then there's another layer. And this maybe looks still very confusing, right? Like it's not really something that you're going to look at and be able to tell a story to the computer and have it do something interesting. But it's another layer on the cake. It looks a little more like English or another language than the binary code. What about something like this? Here you can see some words, right? You can see background, you can see frame rate, you can see some numbers as well. So this is another layer on the cake. This is another computer programming language that uses some words that humans understand, and it also uses the words that the computer understands. And it's a way for us to communicate with the computer. So how many of you have a computer at home? And how many of you have computers in your classroom at school? Okay. So maybe some of the computers that you use, maybe they look like this. Okay. Do they look like that maybe?
No. Much bigger.
Do they look like that?
No.
Yes.
Okay. Do they look like that? Okay. You guys know that these are computers, right? I mean, we think of them as phones, but there's a computer inside of here as well. So we have all these different kinds of computers, and we know that we need language to talk to computers. So how do we learn that language? How do we learn to program? Well, when I was your age, it was a long time ago. It was the 1980s. Okay. And I really liked science, and I really liked math, and I really liked art. And my dad worked with computers, so we had some computers in the house. And the computer that I grew up with when I was a kid was called a Commodore 64. Okay. I'll show you what the computer that I grew up with looked like. That looks really old, right?
They still have those in the library.
Yeah, okay. They also have them in history museums. Yeah. So you guys see that blue screen there? That blue screen is what you would see when you turn the computer on, and it says ready. And it's waiting for you. It was waiting for you to type something into it, but you had to know the language in order to communicate with the computer to tell it what to do. So obviously, we have lots of more advanced computers now. You can touch them, you can talk to them, you can wave your hands over them and communicate with them, right? But what was good about this for me growing up is that I had to learn some of this language. I had to learn some of this computer language. So I used to get a magazine when I was a kid. It was called 321 Contacts magazine. And at the back of the magazine, it had this section called Basic Training. And it had a program. See that blue section on the right-hand side? Does that look a little bit like some of the slides I showed you before?
Yeah.
Or you see some commands to the computer? So what I could do is I could turn on this computer, and I could have my magazine there, and I could type in the commands, and then I would hit go at the end, and something would happen. It would be a little game, or it would draw a picture, or it would make a little animation, or something like that. And I just thought that this was fascinating, because not only did I have a computer that I could use, but I had a computer, and I could tell it what I wanted it to do, right? Or I could learn what somebody else told it to do and make some changes to that, okay? So these days, you're not going to have a Commodore 64, but you might come across something like this. Has anyone heard of a Raspberry Pi? Okay, a couple of you guys. This is kind of a funny name for a computer, right? It's more like something you would eat, but the Raspberry Pi is a very small and very cheap computer. I actually have one right here. You might not even be able to see this because it's so small. This is a little computer. You can plug in a keyboard, a mouse, a display, a screen, and you turn it on, and you've got a computer, and you can start playing with it. And it's good because it's only $35, so schools can get them, or your science club, or your library can get them, and you can start to learn how to program. And there's a programming language on the Raspberry Pi called Scratch. And Scratch is a certain kind of language. See these colorful blocks here, the orange and the purple and the blue? You can drag and drop those blocks together, and that's a way for you to learn how to talk to the computer. So you can say, here are some numbers, and I want you to display this number, or make the cat walk across the screen, or make an animation, or something like that. Those are all things that you can do with this little computer. There's another little computer that's pretty popular right now. It's called an Arduino. Can you say Arduino?
Arduino.
This is also very small. Kind of similar, you can see the circuit board with all the little parts that have been soldered onto it, and you have some inputs and outputs. This is really interesting computer to use because it allows you to interface with a lot of sensors and a lot of different inputs and outputs. Okay, so you're used to using maybe a touch screen or a mouse and a keyboard, and these are all inputs to the computer. And you're used to using monitor or television display or the display on your phone, and those are all outputs. You can also have different kinds of inputs and outputs. So how many of you guys saw this and played with it in the gallery? Good, good. This is one of my sculptures, and inside of it, there's one of these Arduinos. So when you're playing with those joysticks are actually hooked up to this. When I first got the joysticks, they had the red balls on them. I just took those off. And I have little different parts that I have to learn how they fit together. And I put these parts on the Arduino, and then I plug in the joysticks. And the joysticks are pretty simple. They actually just have a bunch of switches inside the joystick, and then they have the part that comes out that you operate. So when you move the joystick to the right, it's actually pressing down a little switch. And when you move it to the left, it's pressing down a different switch. So what's happening is that I have to go from something that's mechanical and electrical, the switch, into the computer in a way that the computer understands, and I can say, when the joystick pushes this little button and it goes right, then I want to do something in the computer. So that's why I use this Arduino in putting this together. And then the actual outside is just made of wood. And then inside I have a computer, another computer besides the Arduino, and another display, like an LCD monitor that's been taken out of its case. You're seeing the back of it there. And then this all gets put inside the wooden box, and all the wires get connected. It looks confusing, but there aren't that many parts, and you would definitely be able to learn how they all fit together. So then we get the actual sculpture, and then in the sculpture you've got the ability to move the joysticks, and the joysticks control those different areas of the screen and make the different graphics come up. And did you put the headphones on as well? So there's also ways that you can tell the computer, when this thing happens, I want to play this sound. So that's what I did. When the joystick on the right moves, I have a certain sound that comes in. And when the joystick on the left moves, I have a different sound that comes in. And all those sounds blend together and add to the artwork as well to give you that interesting experience when you have those headphones on. So let's talk a little bit about an algorithm. The name of this festival is Art and Algorithms, right? Does anyone know what an algorithm is? Does anyone have a guess? What's your guess?
Is it like a computer program that you can use to do art?
I've
heard of it, but I don't know exactly.
Yeah, that's a really good guess. Okay. Let's talk about a peanut butter and jelly sandwich. How many of you like peanut butter and jelly? I like peanut butter and jelly sandwiches. Sometimes I have it for
I
breakfast.
have for lunch.
Okay. If I were to tell somebody who had never seen a peanut butter and jelly sandwich before or never heard of it how to make one, there'd be a bunch of steps, right? We'd have to get some different things together. What do you need for a peanut butter and jelly sandwich? You can just shout it out.
Peanut butter.
Peanut butter, bread, knife, jelly. Okay. So we get all those things together. What would be the first step? Raise your hand. Okay.
Get 2 pieces of bread out.
Okay, so we get 2 pieces of bread out. And then what would the next step be?
Then open the lid and spread it on the bread.
Okay, so open the lid and spread it on the bread. Okay, so let's stop there. Let's think about just that phrase right there. Open the lid and spread it on the bread. Is there a way that we could be more specific? If somebody said, oh, open what? What would you say?
Peanut butter.
Yeah.
Open the peanut butter jar, get a knife, and get some on the knife, and then put it on.
Okay, good, we're getting better. So what if I said, what do you mean by opening the peanut butter jar? I don't know how to open a jar. In fact, I don't even know what a jar is. Okay. Well, what does it mean to screw? Okay. So we're not going to go any further than that, but you understand, like, you have to keep getting more and more precise if the person that you're talking to doesn't have the background knowledge, okay? So all of us understand, we know what a peanut butter jar is, we know how to unscrew the lid off of a jar, but all of that knowledge and all that information we already have in our background because we've learned it as we've grown up or we've been exposed to it, right? But a computer doesn't know these things. You have to be much, much more precise when you're talking to a computer. You have to tell it exactly what you're talking about when you want it to do something, and that's why we need things like programming languages that look a little bit obscure, look a little bit hard to understand, but we have to kind of bring our level of human language down to a place where the computer understands it. Yes?
They have like this website where it's called Cleverbot, and you can talk to a computer.
Cool. Yeah, I mean, we're going to get to a point more and more where we can use our natural language to talk to a computer, but the thing is that in order for that to happen, somebody has to tell the computer how to understand, hear and understand the language, right? So there's almost always going to be a level underneath what you see that enables that to be possible. So you might have seen a piece that looks a little something like this, the canvas print of mine that was in the gallery. So we've been talking about layers of things, right? This image has layers as well. Before it's colored, it's black and white. And before I work on the color and work on the black and white image, I have to tell the computer how to draw this image. And I use an algorithm to do that. And the algorithm, it's not important that you really be able to read it right now, but you can see there's certain numbers that go along with it, and there's certain math equations And I'm telling the computer, based on these math equations and based on these numbers, you can draw these different shades of black and white on the screen. So there's another tool that I'll mention to you that you could learn, as a student that's your age, you could start learning this now. It's called processing. And it's a simple programming language. And if you look at it here, you can see, like we were talking about, you can see some more words that you understand. You can see words like, I think this is, yeah, same slide that I showed before. Background, and finished, and generate, and you can learn those different functions and learn how to talk to the computer. So what you're seeing here is part of a program that I used to draw this picture that I have on this name badge right here. And this is a fancy name badge. How many of you have ever seen a Kindle or something like it? Okay. So this display technology that the Kindle uses is called e-ink. It's like electronic ink. So what's special about this is that normally a display like the one that's on my phone or on my computer or the projector has to have power all the time, right? But with the Kindle or with this little badge right here, I only have to give it power when I'm changing what's on the screen. Then I can turn the power off and it's going to stay that way, almost like I had a pen and paper or a pencil and paper and drew the image on there. That's why it's called e-ink. Here's another image that's from an algorithm that I used programming language to say to the computer, here's how you're going to draw this image. So I can show you real quick. This is the program that generated that last image that I had on the screen. So there's going to be, if you've never done this, obviously there's going to be a lot of things you don't understand, but we could walk through it and we could learn what do these different words mean, what do the letters mean, what do the numbers mean, and what happens when I change the numbers. So the great thing about this is that you can give instructions to the computer and draw things and do things and animate things that no one has ever seen before. You guys also see the animation of the stick people that was on the screen? Good. So inside that program is another algorithm. And that algorithm says when you're a stick person, you're born into the world and you have a certain age. And as you get older in the virtual world, you're going to do different things. So when you become a child, you're going to look for other stick people that are children and you're going to play with them. So you see them dancing like this. That's them playing with each other. And when you get a little bit older, you're going to look for somewhere to build a building. So you see them with the hammers and they're hammering on the domes and the domes get bigger and bigger. So they go, it's all in the computer, but I have given it those instructions, that algorithm, that set of rules, that set of instructions to say, when this happens, do this. And when this happens, do this. Yes?
What about when they're floating?
When they're floating. So they float at the beginning when they are being born. And that's kind of like when a child is being born, before it's being born, it's in its mother's womb. So it's kind of symbolism for that. And then at the end of their life, they float up and they're kind of on their back and they float into the air and they disappear. And that's symbolism for dying. So at the beginning, they're floating, and at the end, they're dying. And in between, they're doing all sorts of different things. And you guys also saw the kites that were hanging as well. So that's a mix of the images that were on those kites were generated from algorithms in the computer. And then I ran that through a printer and printed on that nice thin rice paper, and then built the kites out of the balsa wood and the rice paper and hung them from the ceiling. So that's a good example of mixing things that are coming from the computer with more traditional styles of art, which you'll see a lot of at the festival. So I think we're about out of time. Let me go ahead and ask you guys, do we have time for a few questions?
It's going to be less time for him.
Okay,
but if
all right.
you want, maybe he can speak, and at the end,
Great, sounds good.
we can ask, we can ask kids to ask questions to both of you at the same time.
Sounds good. David,
Thank you
it's all
very
yours.
much.
Thank you guys.